Hello everyone, today we are going to talk about statistics again, and this time we are going to cover normal distribution and especially on how to use our calculator for NormalCdf. So before we get started, let's first take a look at the normal distribution. So we have here something called the bell curve or the empirical rule, which shows the percentile and how the standard deviations above or below the mean. And so we have in the middle is the mean, and then we have 68% of the data that is within one standard deviation of the mean, and then we have 95% within two standard deviations of the mean, and 99.7% within three standard deviations above the mean. So if you take a look at the numbers here, what these represents is how far away from the mean it is. So it is 0 because this is the mean, and then on the right it will be 1 standard deviations above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean. -1 represents -1 standard deviations below the mean, or 2 standard deviations below the mean, and 3 standard deviations below the mean. So now let's take a look at a sample problem and apply our knowledge on normal distribution, and then I'm also going to teach you how to use your calculator. So first of all, we're given the mean. So remember, this symbol here represents the mean in statistics, and then this represents the standard deviation. And what we want to do for the first question is draw a curve with labels and scale representing each distribution. So we want to draw two curves, one for the male and one for the female height. So let's do that. So we are told that it is normally distributed, so then we can draw a normally distributed bell curve. So in the middle is, we're doing male, so the mean is 70, and what we want to draw is, it says the standard deviation is 4 inches, so to the right it will be 70 plus 4, and then 74 plus 4, which is 78, and then 78 plus 4 is 82. And then on the left we do the opposite, so 70 minus 4, which is 66, and then 66 minus 4 is 62, and 62 minus 4 is 58. And so if you also draw in our label in the standard deviation, we have 0, 1, 2, 3, and then -1, -2, and -3. And so now let's take a look at the female height, which is similar to the male, but the idea of how we draw it is the same, but then we just have to plot in different numbers. So the mean is 65 this time, which is given here, and the standard deviation is 3.5. So then 65 plus 3.5, it is 68.5, and then 68.5 plus 3.5 is 72, and then 72 plus 3.5 is 75.5. And then on the left we do the opposite, 65 minus 3.5 is 61.5, and then 61.5 minus 3.5, you get 58, and then 58 minus 3.5, we get 54.5. And so this is the female, and again we can label the standard deviations, and there you have it. That is our bell curve, or normal distribution of the height of males and females. And so now the second question is asking, determine the percentile for someone with the height of 67 for both males and females. So contextually, if you take a look at the male distribution, the height of 67 is located around here. And so that means that we know that the percentile will approximately be less than 50%, because for males, a person with 67 isn't that tall. On the other hand, for females, 67 is around here. So for females, if you have a height of 67, that is considered pretty tall. And so now what we want to do is find the specific percentile. And in order to find the specific percentile, we want to make use of our calculator. So in your calculator, what we want to do for males, because they would ask for males and females, so we're going to do two calculations separately. For male, you want to make use of, in this case, do NormalCdf. And so what you can do in the calculator, in your TI Inspire calculator, is to click on menu and then go to probability and then go to distributions and then go to NormalCdf. So once you've done that, you have four different things that you can put in. It will say the lower bound, the upper bound, the mean, and the standard deviation. And so in your calculator, usually, we have the lower bound, the upper bound, the mean, and the standard deviation. And what you want to do is just plug in all of them. So here, the lower bound is negative infinity, because we want to find the percentile for someone with the height of 67. We don't want to find a person who is above 67. It says with the height of 67, so it's going to be, like, for example, for male, the percentile with a height of 67 is going to be negative infinity to 67, and we just plot in the mean and the standard deviation, and then we get 0.2266. And when you do the calculations, you always want to label, just to be clear. And then once you've labeled them, you get this. And what this means, basically, if you turn that into a percentage, that means that around 22.67 of the male population have a height of 67. So, like we predicted earlier, it's less than 50%, because people who have the height of 67 is not that big, because the mean is 70. So now for female, we do similar things. NormalCdf, and the lower bound and upper bound are the same, but the mean, you just plug in what you're given. 65 for the mean and 3.5 for the standard deviation. Also label them. And then if you put that in the calculator, you get 0.7161. So that means there are around 67.6% of the female population have a height of 67, which is again what we've predicted, because it is above the mean, and there's more people who have a height of 67. So there you have it. That is how you kind of solve for the percentile if you're given a specific height. And now for question 3, moving on, we want to find the population between 73 and 78 inches. So now instead of finding a specific height, we want to find an interval between 73 and 78. And then now we want to shade the region. So for male, approximately 73 is around here, and then 78 is right here. So then around this many of the population for male have a height between 73 and 78 inches. For females, on the other hand, 73 to 78 is like here, which you can see that the proportion is very small, because for females, a height of 73 to 78 inches is rather rare, because we can see that the mean is lower for females than males. So now that we've shaded the regions on the graphs, we want to justify which population have a higher proportion. So just by looking at our shaded region, we can see that the males definitely have higher proportion. And we can justify this because the z-score of 73 and 78 is closer to the mean in male than female. So we can say the male has a higher proportion because the z-score of 73 to 78 inches is closer to the mean compared to females, which is more apart. And then now we want to calculate the value of the larger of the two. So basically what we want to do is just calculate the value for the male and the female. So for males, again, we wanted to use NormalCdf. And this time, for a lower bound and upper bound, we're given 73 and 78 inches. So we're not going to do the negative infinity thing. And then for male, again, you plot in the mean and the standard deviation, which is given here. So just plug that in. And then we get 0.2039. For females, on the other hand, NormalCdf, again, the boundaries are the same, but the mean and standard deviations are different, which is 65 and 3.5. And if you do that on the calculator, you get 0.0110. So contextually, what this means is that around 20% of the male population have a height between 73 and 78 inches. For females, on the other hand, that's only like 1.1%, which is very low. So that means that for males, the proportion is way bigger than the females. And then the fourth question, it is an open-ended question, so we don't need to do that. So I hope this video helps. Basically, one of the main takeaways is you definitely want to know how to make use of the calculator for NormalCdf when it comes to normal distribution. So again, click on menu and then go to probability number 5 and then distributions, which is number 5, and then go to NormalCdf, which is number 2, and then just plug in the numbers. Hope this video helps, and I'll see you next time. Thank you.